These notes are on evaluating polynomial functions. Simply mean we're going to be able to classify what a polynomial is or what type of polynomial we have. All right, so let's get into it. Look at these definitions. Make sure you get these down. All of this you should have written down, but the degree is the highest number exponent, or the biggest exponent in a polynomial. Okay, so if I ask you for the degree, you should know what I'm talking about. It is the biggest exponent. It may be the first one, it may be the last one, it may be in the middle somewhere. Who knows? But it's the biggest exponent. Polynomial is a mathematical sentence with multiple terms. So technically it's not true. It's a mathematical sentence with terms. Sometimes it has multiple terms. Standard form, writing polynomials in descending order of exponents. That means from the left to right, the exponents are getting smaller. Leading coefficient is the coefficient with the term with the highest degree. So it's not always the first one. It's the coefficient that's with the term that has the highest degree, or the biggest exponent. To determine if a polynomial is a function, all exponents must be non-negative numbers. So that's pretty simple. All right, so how to classify them? If you have a polynomial with a degree, what's degree mean? Can't hear ya. SpongeBob. Okay, I couldn't help it. But anyway, the degree is the exponent, the biggest exponent. So the degree is 0, meaning you don't have any variables. The only way you have a degree of 0 is if you actually see it, or you just have a number. That's called a constant. A number by itself is called a constant. And when you look at a graph, it makes sense. It's constant straight across. Linear is if the leading coefficient is 1. If the degree is 1, like y equals mx plus b. Quadratic, which is what we've been spending a lot of time on, the biggest exponent is 2. Cubic, if the biggest exponent is 3. Quartic is the biggest exponent is 4. All right? So let's take a look at this. Identify the degree of each polynomial, of each monomial. Mono is the prefix for 1. Okay, so each one of these is one term. And a term, I've said this before, that's why the definition is not on here. A term is anything separated by a plus or a minus. And so nothing's separated in any of these by a plus or a minus. So it's one term, even though it gets more and more as we go through 1 through 4. So the degree of this one is 2. The biggest exponent is 2 here. The degree of number 2 is 4. What is the leading coefficient? It is 3. Okay? The degree is 4, and the leading coefficient is 3. Now, number 3 is a little tricky. What is the degree of this monomial? Technically, it's 4. Now, this one's a little different, so you might want to write this down, that if you have different variables being multiplied, like in this case, the degree is when you add them together. So the x has 1 and the y has 3. When I say add them, I'm talking about the exponents. So the degree is 4. You never would add them to get one different variable or something if you were multiplying, but in order to determine the degree, you add the different exponents and you get 1 plus 3 is 4. So the degree on number 3 is actually 4. The degree on number 4 now, based on what I just told you here, you should understand that the degree on number 4 is 11. All right, let's quick introduction. Really, in this section of polynomials, we're going to add and subtract them. We're going to multiply and divide them. We've already talked about multiplying, but I'm going to revisit those notes. And we're going to graph them, and we're going to talk about the graphs. And so the first section, after classifying, which is what we just did, is looking at adding and subtracting. And very simply, this is what I tell my students to do. Remove everything out of your parentheses. All right? Now, in order to remove parentheses, you got to know this little quick review. A plus B is just a generic polynomial. It could be a whole bunch of stuff in there, but A plus B is just what I'm using as an example. Here's the options. You could have nothing in front of parentheses. You can have a minus or a negative in front of parentheses. You can have a number. That 2 represents any number, positive or negative. And you could have a plus sign. All right? Your first step to me to make things simple for the person who likes to make mistakes is to always remove your parentheses first. So if there's nothing in front, the way you would remove the parentheses is just rewrite it again, what's inside, without changing any signs. The same thing goes for if there is a plus sign out in front. I could talk to you about why, but I'm running out of time. If there's a negative or a minus, what that does is change every sign inside the parentheses. Now, that don't mean it's always going to be negative, but since both of these are positive, they're both going to change to negative. If one of them is negative, it will switch back to positive. So the minus sign means basically you distribute or multiply a -1 to everything, or just change all the signs. If there's a number, that's distributed properly like all this is, and so you'll take that number times both. All right? So these are the 4 options of removing. Let's go back to those examples. Let's look at number 5 here. So my first example here, I want to remove everything out of the parentheses first. There's nothing in front of this parenthesis. What does the note say if there's nothing? You rewrite it exactly how it looks. There's a minus or a negative sign in front of mine, so what does the note say you do here? Is everything change signs, and so the 3x squared now is the minus 3x squared, minus 2x, and plus 5. Notice I changed both of those, all 3 of those signs. Then you combine like terms. Alright, I like to write things in descending order or standard form, so I'm going to start off with my x squared. Yes, I have 1 here, but I'm going to do x squared first. Negative 1x squared and negative 3x squared make negative 4x squared. I'm done with those 2. Negative 2x is next because it's next in descending order. And then 1 plus 5 is 6. Remember, guys, you always go to the left of any term to see what sign it is. And so that's a negative 2x, that's a plus 5, that's a negative 3x, that's a negative x squared, that's a positive 1. You look to the left, you don't look to the right of each term. Look at number 6. First thing you want to do is remove your parentheses. Notice real quick the order here. There's no order inside the parentheses. Don't let the order throw you off, guys. If it's not in standard form or it's not in the order that you like, it doesn't matter if you understand the rules. 3x squared plus 7 plus x, there's nothing in front, so I rewrite it. There's a plus sign in front, again, so I just rewrite it. 14x squared plus 2 plus x squared minus x. Now, somebody could have noticed that those 2 right there are like terms, and you can combine those. Sure, you could. You could have done that right at the beginning, but I didn't. 3x squared plus 14x squared plus 1x squared, so that's 17x squared plus 1x squared is 18x squared. So I'm done with those. Now what's next? Should I do the constants, the numbers without any variables? No, I should go to x to the first power. So I have x minus x. What's x minus x? It's 0. I don't have to write 0 if there's something else. I already have an 18x there, so I don't have to write plus or minus 0. Next I have 7 plus 2, which is 9. And so that simplifies down to 18x squared plus 9. The first set of notes is classifying using these definitions here, understanding what a degree is, standard form, leading coefficient, how to classify by the name, okay, by the degree actually, excuse me. And then we went into adding and subtracting. All right. So make sure you get this. First lesson is somewhat simple, or hopefully it's simple enough. We'll get into some more complex things later. Got any questions? Jot them down, write them down, so when I'm in class we can talk about them.